There's a number hiding inside the phone in your pocket, and the first man to write it down, about 500 years ago, couldn't stand it. He called it useless. He said working with it felt like mental torture. And yet, here it is, running your world. Your phone, the scanner at the hospital, the power lines out your window. So how does a number people swore was imaginary end up running everything that's real? Here's something most of us never stop to think about. Anything that moves in a rhythm is really carrying two secrets, not one. How big it is. And when it peaks, the power in your walls swings back and forth 60 times a second. So to describe it, you need the size of that swing and the timing of it. Two numbers, but a plain old number only has room for one, and the only thing that could hold both of them had a very strange name. We call them imaginary numbers, and honestly, that word does a lot of damage. It makes them sound made up, like a trick. But that name was never a description. It was an insult, tossed off back in the 1500s, that just never went away. And here's what's easy to forget. Every kind of number got called impossible at some point. Negatives, fractions, the square root of 2, and every single time, we were the ones who turned out to be wrong. The person who finally saw through it wasn't a mathematician. He was an engineer trying to keep the lights on. Picture the 1890s. The whole world is racing to electrify, and quietly, the math is crushing the engineers. Every circuit meant pages of trigonometry. A single current could eat up an entire afternoon. It was actually holding back the electrification of the planet. Then a man named Charles Steinmetz looks at all of it and asks a different question. What if we stopped treating these waves as waves? And in 1893, he takes work that used to swallow weeks and turns it into simple algebra. So, what did he actually do? Take a single arrow and spin it in a circle. Now, watch its shadow. As the arrow turns, that shadow traces out a perfect wave. So, the wave in your walls is just the shadow of something spinning? And here's the trick. In a circuit, everything spins at the same speed, all locked together like one stiff pinwheel. So why keep chasing the spin? Just freeze it. What's left is simple. How long the arrow is and which way it points. The length is how big. The angle is the timing. That second secret we couldn't store. Engineers call that frozen arrow a phasor. But arrows don't only add. Sometimes you have to multiply them. And that's the moment this so-called impossible number finally shows its face. Forget square roots for a second. Just watch a point. Multiply it by -1, and it flips to the far side, a half turn. Now, the sneaky question. What could you do twice and land on that same flip? A quarter turn, 90 degrees. Do it once, you're pointing straight up. Do it again. You drop right onto -1. So, a quarter turn times itself gives you -1, and that, right there, is the square root of -1. It was never a paradox. It's a rotation, off the flat line, into a brand new direction. And that direction is exactly where the timing was hiding all along. Oh, and engineers write this one as J, not I. The letter I was already taken, it means electric current. Once you see it as a rotation, one formula ties the whole thing together. That spinning arrow and a cosine and a sine, they're the same thing wearing two different outfits. That's Euler's formula, and engineers treat it like a master key. Here's one reason. Multiply two of these arrows and their angles simply add. So every phase shift in a circuit quietly turns into addition, and it goes further. Push a spinning signal through a coil of wire, and the current comes out a quarter turn behind. Through a capacitor, a quarter turn ahead. So that little J isn't just bookkeeping. It's the 90-degree shift, built right in. And nowhere does that pay off more than in the thing you're probably holding right now. When your phone sends data, it doesn't send one wave, it sends two. Same frequency, but a quarter turn apart. Engineers call them I and Q, and together they make a single complex number. So every chunk of your data becomes a point on this grid. It's called a constellation, and it's the very same plane we just built. When your router brags about 256 QAM, that's literally 256 points packed onto the complex plane. But the air between you and the router is messy, and every point shows up shoved off target. So the receiver works out exactly how the air bent it and divides that back out. Your Wi-Fi doesn't just use this number. Your Wi-Fi is this number. An MRI pulls off something that sounds impossible. It doesn't take a picture, not directly. It's got two coils, one real, one imaginary, and all it writes down is complex numbers, row after row. What they capture isn't your body. It's the mathematical transform of your body. Then a computer runs those numbers backward, and your anatomy just appears out of pure math. The picture was never in the machine, and that same idea is holding up the power grid tonight. Remember that timing a plane number couldn't store? On the grid, they call it reactive power, energy that sloshes back and forth without doing real work. But if nobody balances it, every second, the voltage caves in and the lights go out. So is this just a clever human tool or something deeper? For a long time, you could shrug all this off as convenient. Just a shortcut. Something we could always rewrite with plain real numbers if we ever really wanted to. And then physics pushed back. Down at the quantum level, everything is waves, and waves interfere. Line their timing up, you get brightness, push them opposite, they cancel to nothing. And that interference runs on complex numbers. So around 2021, physicists actually ran the test. They built a version of quantum theory using only real numbers, and asked a simple thing. Does it predict the same universe? It doesn't. The experiment sided with the complex version. Which means this might not be a human invention at all. Nature itself might just run on these numbers. So, think back to where we started. A number they called imaginary. Impossible. Useless. But the world it actually describes, anything that swings or spins or ripples through the air, that world was never a straight line. It always had two dimensions, size and timing. We just couldn't see the second one. The real mistake was never inventing this number. It was believing that flat little line was the whole story. Every signal your phone locks onto, every scan that sees inside somebody, every second the grid holds the lights steady, this impossible number is quietly doing the work. The one that's not supposed to exist. Turns out it might be the most real thing we've got.